Alright, let's look at practice exam 1, problem number 9. Alright, so let's use the precise definition to prove that the limit of x squared minus 1 as x approaches negative 2 is equal to 3. Alright, so let's do the scratch work first. Alright, so we have, let's say f of x is x squared minus 1, and a minus limit value is 3. So we know that this is the conclusion we want to make, less than epsilon, right? Then somehow we want to relate this to x minus a, which is x minus negative 2. So we're talking about the x minus negative, so plus 2 with the absolute value, right? So we have that. All right, so let's simplify this. So we have, let's see, negative 1 minus 3 would be x squared minus 4 is less than epsilon. Then we can factor this out as x plus 2 and x minus 2 is less than epsilon. All right. The guy we're interested in is x plus 2 right here. So I'm going to divide through by absolute value of x minus 2, right? So you have x plus 2 is less than epsilon over absolute value of x minus 2. Right. Then what we're going to do is we're going to make a extra assumption. So we're going to assume that delta is less than equal to 1, right? Which means that x plus 2 absolute value is less than 1, right? Which is equivalent to x plus 2 is between negative 1 and a positive 1. Right? Since we want to know the bound for this guy, x minus 2, so I'm going to subtract 4 to make x minus 2 instead of x plus 2. Right? So here I'm going to subtract 4. So we have a negative 5 is less than x minus 2 is less than minus 3, right? Then you can see that here it tells you that let's see, right? If x minus 2 is between negative 5 and negative 3, if you take the absolute value of that, then largest it could be would be 5, right? So we can use that to use this inequality to get this inequality. So when you compare epsilon over absolute value of x minus 2 and epsilon over 5, right? Since 5 is larger than absolute value of x minus 2, you have a larger denominator, so the fraction is going to be smaller. Right? Then we get to proof. Right? So here's the proof. Right, so for all epsilon greater than 0, there exists delta. So since we made an assumption that the delta is less than or equal to 1, so we're going to do a minimum of 1 or epsilon over 5. Right? So this is going to be the delta value. Right? So this is greater than 0 such that, right, if absolute value of x minus a, in this case minus a is negative 2, is between 0 and the delta, right? Then we can assume two things, right? So since delta is smaller of 1 and epsilon over 5, so we know that this quantity, absolute value of x minus negative 2 is same thing as plus 2, is going to be less than 1. And at the same time, we know that absolute value of x plus 2 is less than epsilon over 5, right? So from the first inequality, we can get this. We basically do, we copy this part right here, right? So we have, right, this means that the x plus 2 is between negative 1 and the positive 1, right? Then I'm going to subtract 4, right? Because I want to make x minus 2, right? So it's a negative between negative 5 and so x minus 2 is negative 3, right? And since x minus 2 between negative 5 and negative 3, we know that the absolute value is going to be less than 5 because it's between negative 3 and negative 5. Alright, then we can just make this inequality. So epsilon over 5 is going to be less than, alright, 3 over, not 3, epsilon over x, absolute value of x minus 2, right? Since we know that this inequality comes from here, right? Since the x minus 2, absolute value of x minus 2 is less than 5, so we are making the denominator smaller, so the fraction is larger, right? So we have that. Alright, so from there, we can get this inequality by multiply both sides by absolute value of x minus 2. We get the absolute value of x squared minus 4 is less than, and absolute value of x minus 2 cancel out with epsilon. And then we can rewrite it as x minus 2, x squared minus 1 minus 3 is less than epsilon, and which is what we wanted to get. Right? So by assuming that the epsilon delta is less than 1, we could assume that absolute value of x minus, we could use the inequality absolute value of x minus 2 is less than 5, which will allow us to have this inequality there. All right, that's it. I hope that this was clear.